This presentation will it's about the geological and geomorphological insight from multi-satellite remote sensing data. So we selected one case studies from Pakistan, and then we look uh, to the worldwide what other people have using the same techniques. So there is no work so far uh, done regarding the geoheritage potential. If I just define the word geoheritage or geological heritage as the similar things, the same geology, and it's you can say a kind of descriptive term that is used for geological entity that have any scientific values. So if you look around the world, there are about 48 countries that have 195 geoheritage sites. So if you look around the world, there are about 48 countries that have 195 geoheritage sites. And so far, if you look to our neighbor countries like Iran, if you look to Iran and China, uh, hmm? Yes, sorry, okay, it's not changing. It's changing now. Yeah, this is, yeah, okay. So I will go to the main objectives. Okay, I'm not going to the details of what is done so far in case of geoheritage, but this topic is very important because they are integrating the remote sensing data with the selecting the geoheritage sites. So the objective of this work is to establish the geoheritage inventory of Pakistan with integration of mapping, petrology, stratigraphy, and remote sensing data. So I already have papers on this, integrating the mapping, the petrology, and stratigraphy. But now this data, integrating the remote sensing images, and making some information from Landsat 9 and and Sentinel 2B dataset. So we selected these two kind of data set for our geoheritage. So the next slide is this one. So why we are doing such things and why we are selecting such kind of data? What are the preliminary importance of this kind of data? So all these things will help to examine the global geopark networks. So there are certain criteria for this network, and this criteria may be like you all know the World Heritage criteria, that it can include the cultural and natural things. So we need to incorporate those remote sensing images and find out which side is best for our geoheritage area. So and for methodology, we are moving to the Landsat 9 images and Sentinel to help and control all the geological features, and then integrate with some investigations that could be the field investigation. So we use the technique of PCA, band ratios, FCCs, and SIC. And probably in the yesterday, I didn't attend the whole session, but I hear that you already have some presentation on PCA and BRs, ratios, and everything. So we use these techniques to encounter the geoheritage features. So for this, we propose three basic sites, and I just take only one site here to this presentation. That is the geoheritage of southern Pakistan that belongs to the Balochistan district, and that is Hangol National Park area. Then we have Salt Range, and then we can have to the northern Pakistan. That is the Garam Chashma granitic batholiths. So worldwide studies, that's this kind of study is very important. It was done in 2021, and I was the reviewer of this paper. This is a very good paper. Geological and geomorphological features of a volcanic field. This is situated near, you can see that's in Medina city. So this all volcanic eruption are in series and they are located around this close to the Medina city. So what they did, they so collected the lens in 8 images, and then the Gaufen 2 GF2 dataset. This kind of dataset is acquired from China satellite observatory. Probably this was launched in 2014, and then this author used in 2021. This author done very excellent job by integrating those two dataset images and then find out what could be the possible UNESCO Global Geoparks and King Saudi Arabia. You can study this paper in detail. But if you see to this kind of images, they have given these numbers to those images from GF2 image, and that could these 1, 2, 3, and 4 that represent the eruption of the volcano, and then you can say the series of the eruption from sequences, which one is early, which one is late, and which one is in the middle. You can see the one GF the one series is quite close to the Medina city, so that is younger one, and then the other one are the older ones. So I just want to see that how it works, like GF, the air satellite images. Close to this image, we have some dark colors and then light colors and then some light green colors. So they have again used the RGB 431. And I think it's okay. So this image, as I told you, these images they have used the 341 RGB, and that can best explain the eruptive mechanism around the Medina city, the volcanic eruption, and the series of volcanic eruptions. So 1, 2, 3, 4. They have divided these based on the similarities of the RGB colors, and the which one is older and how first older one and younger one has been erupted. So they have a 3D perspective. You can see that this arrows is showing the direction of the flow around the city, and based on these directions and based on these colors, and RGB values, they have decided that this could be a good geopark. And if you can see, can you see this image?
Yes, we can see.
Okay,
Yes,
so
sir.
this image they have just okay, they have just created a 3D view of this Medina volcanic fields, Al Medina volcanic fields, and if you and you can see there are three arrows, and they have shown the lava directions, which one is early, which one is late, and which one could be. And they have very little evidences from field, although they have very good studies from satellite images. So these 3D reveals that the lava generated in different eruptions and how they are like they're related to the events of their activities. I just copy these 4 or 5 images and make it very simple. Although the paper is available, you can read this paper, The Potential of Al Madina Volcanic Fields from Satellite Images, and Geoheritage Science Journal. This is very high impact vector journal. So, looking to these studies and the gap, we suggested that we should also work on the same thing but with different images. And so far what kind of data is available and what field evidences what we can collect in Pakistan. So far this was the study, yet first ever integration of the remote sensing with the geoheritage. And but such approach is not available for documenting the geoheritage in Pakistan. However, Kasi et al. These are volcanoes that occur all around the Awaran Hills. So they have identified these on the Landsat 5 thermal images with the band ratios 3 to 1. You can see it in the next image. So we selected three sites, and I have just included this Hengol National Park that is in the southern part of Pakistan. And you all know that it's very active because of this nature of the three major tectonic plates, Eurasian, Arabian, and the Indian plate. So their succession is continues from Cretaceous to Paleogene Milan zones. So for the first time, these features are highlighted and they are correlated with the World UNESCO World Heritage Sites, and where we have find out 14 geological heritage and around about 10 notable geological features. This study is already available and it's published. But to continue this with the remote sensing, it's currently going on. So this is just the park distribution, the land cover maps, the geological map, something you can see that they. And if you look to this, this is Arabian Sea, Gawadar, Las Bela, and Avaran. So it's a big park you can see uh, where this is located around three districts: Las Bela, Avaran, and Gawadar. So you can see the satellite image, but the information is not really clear. So, and this is a geological map we encounter from the field works, where the red shows mostly the mud volcanoes, because the mud volcano series are very common, and there are volcanic. So confirming it from the field evidences and collecting data and then correlating it with the remote sensing. So this was the study on the band ratio 3 to 1 RGBs. You can see that the red line is showing the series of the mud volcanoes, and this is around about 14 or 15 mud volcanoes that are very common in around this Hangor National Park. You can see this table. We have many different names to them. Probably you have here those names. Chandragup is one of the best name for the mud volcanoes, and it's very culturally also very important and other things. So you can see these 14 clusters of volcanoes, and these are all mud volcanoes that's around this Hangol National Park. They are located. So the study, uh, just this image is 321. Just highlight the this image. If you can close up this image, you can easily see that how this crater of this volcano is clearly distinguished from the contact rocks, you can say the host rock. So this is our field criterion for the Hangol National Park, and we use these as a field evidences because you all know that for remote sensing you must have field evidences, because at least you have some spectral analysis from samples, you have field work, you have complete control on your stratigraphy, then you can go to your remote sensing analysis. So these all show that they have majority are limestone and then sandstone. And again, if you can see, they are all geomorphic features. And not I'm not going to the complete detail of all these things, but trying to correlate these with the field, the remote sensing data. And this image, you can see that this is a very good image about like you can see this Makran coastal highway that's all run around this to and reach to this Arabian Sea. And these mud volcanoes, if you see, they are all located in a cluster of series of mud volcanoes. So what we done in the data processing, we use the band ratioing as last yesterday. I don't. Yesterday it was explained that how it works. The band ratioing, dividing one ratio with another one, and making image so enhanced so that you can give the good information. So for this reason, we use these ratios 8, 11, 11, 12, 12, 7, and then again to these three kind of ratios we use. And these are very important because they can easily differentiate between structures, geological features, and that can be very important for marking their boundaries. So we use first this band ratioing. These are the images you can see. These are very the area is very high, so the images you can see is around like they cannot be covered in this single slide, so I may combine all these things. And you can see that the RGB tie-up ratios here, for another RGB ratio here, and for another RGB ratios here. So you can clearly see, because based on these colors, you can clearly see the structure continuation and the structural trends that and their color similarities. So, and then we further enhance this, but that's for the Sentinel 2B data. And then for again, for the color composite, we use the similar ratios for the FCC, false color composite. And you can see that again, based on their similar structures, similarities in their structural affinities, we can say that which formation is lying in which place, what kind of structure is available, and how we can differentiate between these two features. So the FCC RGB 321, and then the RGB 213 again, and then the same ratios for 712. You can see these images. They can clearly differentiate between like you can see the light gray and the pinkish gray and the yellowish and then the light gray. So all these color have similar affinities. So those that possess similar affinities, and based on the spectral data from fieldwork, so they can be regarded as a similar geological features. So, and further enhancing those results with the PCA, you all know that this is a kind of statistical analysis that can be done by softwares. So, this first you need to make a mega stake, and then you need to have these band 1 to 3 for again for this PCA. So this image within these Birkini formations and are around the Ormara formation. So all these one light gray curves. So you can clearly formations, and of course between these mud volcanoes from in association with the fieldworks. And these two are the stakes. If they are all aligned, so it means that your data is good. And then similarly, we use the technique of SIC, that is the supervised image classification techniques. In this technique, you can see that we divided these all formations in their series, like the mud volcanoes, then the sediments, recent sedimentary rocks, then Ormara formation, Henglas, Pirkini, and some water bodies. And this all information comes from, you already have geological field data, your existing data. And then if there is any kind of previous geological maps are available, then you can make those information as a base map, and then you can make your own map based on those Landsat 9 and Sentinel 2B data set. So these both, if you compare them, they are clearly differentiating between the similar formation and the similar series of rocks and beyond the structures. And then again, you can see for Sentinel 2B, the series of RGB ratio is used, and this can further enhance the image that those who are in similar affinities, they have the same formation, and then those who are in different have different formation. Like this one, they have the false color composite, and in that image, if you see these, that can clearly give you the information about the exclusive mud, the mud, like the mud volcanoes. In general terms, you can use the mud volcanoes, and all those they are associated all around these Ormara and Hengland formations. And then we came to the comparative analysis between the global geoparks studies where these are located. So you can see that this kind of study that happens in King Saudi Arabia because of the mud volcanoes, volcanic rocks. They have the process data are based on the remote sensing data. This is our work. That is agency. This is already published. You have seen these images that there are some rare white volcanoes and some. So they have used the techniques of the RGB only. Although we apply the SIC, PCA, some other techniques, and then they combine it, and then we can easily say that what kind of diversity of rocks are available and how it can be helpful and integrating the geographic. Similar, like in this Yukon, UNESCO Global Geopark that is in the southern part of China. So they all have the same results. And then if you look to the Hong Kong, this is also global geopark, and they also have volcanic activities and variety of signature rocks. We have similar case with HNP, and then Greece kind of geopark is also located, and it's so similar phenotypes because of the varieties of volcanic rocks in these islands and some jagged deposits. So this is so clearly demonstrated how they are closely correlated. So we come to the conclusion. So you can easily say that additional criterion. This part is first two part is already published, and then I will give the link to the paper in the next slide. This information comes from field works, and then so there's also field work, economic, geological, and all of the information may come from field work. You need to integrate those information with the remote sensing data, and then you can easily infer that the mud volcano was also mud is classified within the side. And then I can say with other image classification. So that's good, like how it can be integrated in the remote sensing data analysis. So my selected publication, you can see that should be from this one, geological and geological characteristics, and then some other related publications. And thank you so much. And then I'm not sure why I have finished quickly, I don't know, but it's done. So if you have any question, you can ask. Yes. Yeah. Okay, and like my case, I have selected those exact 9 and 10 data. Why I have selected this? Because you need to first find out the like geological and stratigraphic control of the study. Like, for example, you have the mudstone and for example the volcanic rocks. So you will look into the other studies is what kind of like available data set is helpful to find out those data. Then you can go for selecting the appropriate band ratios. So for this, I will say that you need your basic literature data, and then you can calculate related, which mostly those data are available, so that's why we use those data.